What if I told you that a 180-meter mega dam wasn't built by human hands?
Imagine the world's largest 3D printer. Now, imagine it printing a mountain of solid concrete. The Tibetan Plateau is brutal. Freezing temperatures, deadly altitudes, and shifts.
5 billion kilowatt hours of power. A 180-meter wall of impenetrable stone. High on the Tibetan Plateau, an unprecedented engineering marvel is taking shape.
This is the untamed Yellow River. Soon, it will power millions.
The Yangkou hydropower project aims to generate 5 billion kilowatt hours annually.
But building a 180-meter tall dam at this altitude requires a revolution in construction.
The harsh environment is too dangerous for traditional manual labor. The solution? Turn the entire construction site into the world's largest 3D printer.
Phase 1 begins with preparing the foundation, carving into the ancient bedrock.
Crews clear loose stone to ensure the massive structure will have a solid anchor. Millions of tons of earth are moved to shape the footprint of the dam. Once the bedrock is exposed and verified, the human element steps back.
The heart of the Yangkou project is not a machine, but an advanced artificial intelligence. This central AI acts as the brain, coordinating a massive swarm of autonomous machinery. Processing millions of data points per second, the AI eliminates dangerous human error.
Human overseers monitor the system, but the AI dictates the physical labor. The swarm arrives. A fully unmanned fleet of heavy construction vehicles. No drivers, no fatigue, just pure, relentless, calculated efficiency. Guided by satellite navigation and localized sensors, they move with millimeter precision. The process starts at the automated quarries, mining the raw materials. Unmanned trucks transport the raw stone to the crushing facilities. Here, the stone is pulverized into aggregate, the backbone of the dam structure. Every step is monitored. The AI adjusts the crushing speed based on material demand. The materials are combined to create a specialized concrete mixture. Engineered specifically to cure perfectly in the freezing, high-altitude conditions. The AI dispatches trucks exactly when the mix is ready, preventing any waste. The printing material is loaded. The massive 3D printer is fueled. These robotic couriers navigate complex terrain, constantly communicating with the central brain. Traffic is managed flawlessly. No bottlenecks, no delays. Arriving at the precise coordinate, the material is ready to be deposited. Next comes compaction. The rollers press the air out of the material.
This locks the aggregate and concrete together, giving the dam its immense strength.
Real-time density sensors scan the compacted layer continuously.
The AI analyzes the density. If it's too loose, the roller is ordered to make another pass.
Perfection is not a goal. It is a mandatory parameter. Slice by slice,
Layer by layer, the structure begins to rise from the bedrock. Humans need sleep. The AI swarm does not.
Operations run 24 hours a day, 7 days a week.
Human supervisors rotate shifts to monitor the system's health, but the machines never stop.
High altitude brings freezing temperatures and unpredictable weather.
Weeks turn into months. The footprint of the dam is massive. Hundreds of vehicles operate in a complex ballet, avoiding collisions with algorithmic perfection.
The logistics chain is fully integrated. The AI senses low supplies.
It automatically orders more raw materials from regional supply hubs.
Maintenance is predictive. The AI knows when a machine needs service before it breaks.
A replacement is instantly deployed, ensuring zero downtime on the print surface. Looking closely, the printed nature of the dam is visible in its perfectly stacked layers. The physical structure matches the digital blueprint down to the millimeter. For areas requiring tensile strength, automated cranes lower steel reinforcements. The 3D printing process seamlessly integrates with traditional reinforcement.
Approaching the halfway mark, the scale of the structure is breathtaking. While the dam rises, the mighty Yellow River is temporarily bypassed through mountain tunnels.
The AI optimizes the vehicle patterns, creating swarm behaviors similar to ants or bees. It cleans up after itself, ensuring the site remains free of hazardous debris.
Computer vision cameras act as the AI's eyes, constantly scanning for anomalies.
If a foreign object enters the print area, the system halts the immediate machines.
Day after day, the relentless pace outstrips traditional human construction by years.
Workplace fatalities and injuries, once a grim reality of megaprojects, are entirely eliminated here.
When a machine is empty, it instinctively yields the right of way.
Another machine seamlessly picks up the exact coordinates and continues the pour.
The empty unit returns to base, an endless loop of efficiency.
From above, the massive structure looks exactly like a desktop 3D print, scaled up to a mountain. The upstream face, which will hold back the water, requires a specialized waterproof concrete face.
Slip-form pavers defy gravity, perfectly shaping the angled water barrier.
Human quality control verifies the AI's work. The margin of error is virtually zero.
By using local materials, the project drastically reduces its carbon footprint. No long-haul transport. Everything required to build the dam is sourced from the surrounding mountains. Passing the 100-meter threshold, the altitude winds become severe. The AI compensates for the wind shear, adjusting the steering and speed of every vehicle in real time. Embedded sensors inside the completed layers transmit internal stress data back to the brain.
The foundation is solid. The core is flawless. The printing accelerates. To save time, the AI divides the surface into zones, printing them in parallel. The machines collaborate. If one zone falls behind, resources are dynamically reallocated. dense Tibetan fog rolls in, blinding human eyes. But the machines don't need eyes. They navigate by GPS and radar.
Production continues flawlessly, unhindered by the extreme elements. The final vertical meters approach. The 180-meter zenith is in sight.
It is time to integrate the massive penstocks, the arteries of the hydropower plant. The AI meticulously prints the dam around these massive pipes, sealing them permanently in stone.
While the top is still being printed, human crews install the massive turbines below.
Here, human expertise meets the AI's structural perfection. The batching plant prepares the capping layer. The final pour.
The fleet makes its final ascent to the crest of the dam.
The cap is laid. The 3D printing process is physically complete.
The autonomous machines quietly return to base, their monumental task finished.
The world's largest 3D printed structure stands complete. Built without human hands touching the concrete, yet born of human ingenuity. Now, the true test begins. Harnessing the river. The diversion tunnels are closed off. The river, blocked from its path, begins to press against the printed wall.
Sensors embedded in the printed layers activate, monitoring the immense water pressure.
The structure holds perfectly. The AI's precision proves flawless.
The Yanku Reservoir begins to form, creating a massive artificial lake.
Millions of gallons of water are captured, storing immense potential energy.
The water level reaches the critical threshold for power generation.
The intake valves are opened. Gravity forces the water down the penstocks at terrifying speeds.
The raw kinetic energy strikes the hydro turbines. The turbines spin, transforming the river's fury into rotational energy.
Electromagnets generate massive amounts of electrical current. The first unit comes online, pushing power to the grid. Clean, renewable energy surges out across the Tibetan Plateau. 5 billion kilowatt-hours annually, destined for millions of homes in Hainan province. A monumental victory for engineering, pushing the boundaries of what is possible.
The landscape is forever changed. A wild river tamed by algorithms and steel.
The Yanku Dam proves that autonomous 3D printing is no longer science fiction.
It is a blueprint for the future of infrastructure.
Faster, safer, and more efficient than any project before it.
As the sun set on the Yanku project, a new era of construction dawns.
The machines have finished their work. The river now does its part. The swarm rests, waiting for the next mountain to conquer.
silent, strong, and unyielding.
The Yangkou Hydropower Project, a testament to the power of artificial intelligence.
And the unstoppable force of human innovation.